Since so many of you guys like these practice tests that I put together, I figured I would do another one. And now these are not all multiple choice. I have stayed away from the Technician A and Technician B questions because they're so unpopular. But some of these are short answer questions. A lot of people don't like short answer questions, and instructors don't particularly care for them because it makes the test more difficult to grade. On the other hand, it's kind of subjective because you have to, if you're an instructor, you have to determine if the person knows what they're talking about when they answer the question. Okay, so let's get started with this one here. This one here, a thermostat is rated at 195 degrees. What is this? Is this the opening temperature, the fully open temperature, the temperature in the radiator before the thermostat opens, or the temperature the coolant fan comes on? What is that? I got a dandy little picture of a thermostat there for you to look at. Here's the next one. Joe puts his car in neutral while coasting down a mile-long hill in Arizona. This will cause the vehicle to burn more gas than if left in gear. It will cause the vehicle to run too cold. It will prevent the torque converter from overheating, and it will trigger a P1270 DTC. Which one of those is the right one? Alright, a spark plug suddenly fails and stops firing while the engine is at highway cruise. I actually misspelled cruise, and that just drives me up the wall when I see a misspelled word that somebody else put down, and it bugs me even more when I see one that I put there. The PCM-ECM will instantly interpret this as what? Rich exhaust, lean exhaust, evaporative leak, or a quad driver failure. The header pipe has developed a crack/leak between the O2 sensor and the engine. This will likely do what? Will it drive lambda readings low, lock lambda at 1.0, drive lambda readings high, or set a downstream O2 code? The EGR valve suddenly sticks partially open when commanded closed. This will cause what? The O2 to show a lean mixture, the O2 to show a rich mixture, manifold vacuum to increase, or a P0401 code. You can pause these anytime you want to if you need to look at the answers. Of course, you know that. A lean air fuel mixture burns what? Cold and fast, hot and slow, or cold and slow. An engine has an IHC reading of 2% at idle. The most probable cause might be the engine may have a vacuum leak, the IAC needs replacing, the engine is running rich, or the throttle body is dirty. As engine load increases, what happens? A, manifold pressure increases. B, manifold vacuum increases. C, ignition timing advances. Or D, injector pulse is reduced. Question 9. An engine has good fuel and fuel pressure is what I meant to put, good strong spark, clean spark plug, and good compression, but it won't start. The engine will start with any 2 spark plugs removed. What does that mean? Question number 10. A rounded off exhaust cam lobe will cause what? A, a burned valve. B, exhaust backfire. C, induction backfire, or D, a clogged converter. Enhanced live data shows the intake air temperature sensor reading is 101 degrees Fahrenheit and engine coolant temperature reads 40 degrees. The ambient temperature is 38 degrees Fahrenheit. What will the OBD2 generic data live stream show on these 2 sensors on the same vehicle? There's your place where you write your IAT, and there's your ECT. Question 12. The parts store pulled a P0128 and a P0172 on a customer's vehicle due to an MIL, but the customer decided to ignore the codes and just change the oil and filter. Immediately after the oil change, the engine won't idle. It was fine before, and he did everything right while changing the oil. In other words, he didn't leave anything unplugged or anything like that. All he did was change the oil, and he did it exactly the right way. He even used the right kind of oil. Explain this. During roadside assistance in Panama City, Florida, you find these live data readings on a mill light diagnosis. What's the reason for the high long fuel trim reading? But you might notice that short fuel trims at 1% more or less, long fuel trims at plus 27, RPMs at 650, closed throttle angles at 10%, throttle angles at 10%, which means it's at closed throttle, idling. Mass airflow volts is 0.79, and baro in inches Hg is 24. A Pontiac with a 3.4 liter is being checked for a very rough idle, but runs fine at road speed. You start the cold engine and notice the intake manifold becomes too hot to touch within 90 seconds of engine start. What's the first thing you can think of that would cause this? An engine with surge at low speeds is being diagnosed, and the first thing you notice is that some of the plugs look like this one. What causes this? Using the readings below, calculate the barometric pressure. Question 17 on the same screenshot. Based on this live data, which component should probably be replaced? Write it down here below. Question 18. A snap compression test yields this result. Which one of these might be the cause? Now this is dynamic compression testing, where you've got the compression gauge installed in one of the spark plug holes, the one you're checking at the time. And in other words, you move it from one hole to the next. And then you have a static compression reading that you read whenever you're just spinning it over. Then you've got one you take at idle, and then you've got another one you take when you snap the throttle with the engine running and in that hole. This one's given 85 psi on the snap test. So what might be the cause? A, worn exhaust valve cam load. B, worn intake valve cam load. C, burned intake valve. D, loose exhaust valve adjustment setting, which would be on a Honda. Here's one right here that's really tricky. An 87 Honda Accord has blue smoke at the tailpipe, unusually high compression, and this vacuum waveform. This means A, the piston rings are worn. B, the valve stem seals are seeping. C, the camshaft timing is advanced by 1 tooth. Or D, the motor oil viscosity is too low. Question 19. Study this waveform carefully and think. This is exhaust pulse. This is intake pulse. This is relative compression, spinning it over. This is not with the engine running, this is spinning. And this is a number 4 cop coil pulse. So they've actually disabled the fuel system, but they're letting the ignition pulse still continue. And they've got it so that whenever the engine is spinning, you can basically look at all of these readings at the same time. Based on these waveforms, how many cylinders does this engine have? Question 20. Which of these cylinders has low compression? Question 21. How many degrees of crankshaft rotation between A and A? This is a number 4 cylinder pressure waveform with the engine running. Identify the part of the waveform corresponding with valve overlap. Which valve is open at position C? Identify the part of the waveform where the intake valve is open. How many degrees of camshaft rotation are there between A and A? All right, I'm going to stop right there, and I'm going to build another video right now, and we're going to go over each one of those questions. So in order to test your answer, in other words, to check your answers and see how well you did on the test, you're going to have to watch the next video, which will be released right after this one.